Hello everyone. You're welcome to another episode of Mathematics Tutorials on Facebook. My name is Eric. Now, in this episode, we're going to find a solution to this question that was posted on Facebook. So I decided to bring this question for us to solve it. I actually posted it on my page, but then nobody attempted it for reasons I do not know. But here we are to find a solution to it. All right, this is on menstruation. So now looking at this diagram, we can see that the diagram is made up of four figures: a rectangle, a semicircle, and a triangle. So if we are to find the area of the shaded region, that means if we are able to find the area of the rectangle, and then we know the area of the semicircle, and we know the area of the triangle, when we find the sum of the area of the triangle and the semicircle and subtract it from the area of the rectangle, what will be left is the area of the shaded region. All right. So now, what we need to do here is that we need to find to be able to find the what do you call it? The radius of the semicircle. We need, or the diameter of the semicircle, we need to find the um, the hypotenuse of the triangle AEF. If we are able to find the hypotenuse of the triangle AEF, then the hypotenuse of the triangle AEF will serve as the diameter of the um, semicircle. And then, of course, the center half of it will then divide whatever we get as the diameter, and we'll be able to have the radius. All right. So there are some adjustments that we need to make to this diagram. So first of all, let's try to put, this is A here. Let's try to put B here. Let's try to put C here. And then let's try to put D over here. All right. So we have rectangle ABCD. All right. All right. Now, let's put O. Let's locate O here at the center. So let's have O over here. All right. So now what we're going to do is, firstly, let's find the hypotenuse of the right angle triangle to serve as the diameter of the semicircle. All right. So now we say that using Pythagoras, we can decide to write it or not. So we can say that from the diagram, which I can just say that from the diagram, we can say Fe squared. So Fe, let's try to put it here. Let's say that Fe squared is equal to AF squared plus AE squared. All right. All right. So now, what is our FE? We do not know. What is our AF? AF is 16. So this is going to be, so FE squared is going to be 16 squared. That is the 16 squared plus AE is equal to what is our AE? AF is equal to 12. No, so we have 12 over here. Our AE is equal to 16, so we shall put 16 squared over here. So this will be equal to, so FE squared will be equal to 12 squared is 144. So we have 144 plus 16 squared is 16 times 16. That will give us 256, 256. And so this is going to give us Fe squared to be equal to 144 plus 256. What will that give us? That will give us 144 plus 256. That will be equal to 400. So this will give us 400. So we have Fe to be equal to the square root plus or minus the square root of 400. And so our Fe is equal to 20. All right, so we have 20. Now, it's positive or negative 20, but then we can't have the hypotenuse of a triangle to be a negative figure. So we discard the negative figure and take the positive figure of what? 20. All right. All right. So let's rule this line over here because we are going to make use of this space in future or sometime now. So now we have Fe to be equal to 20. So if Fe is equal to 20, then it means that Fo is equal to 10, and then OE is also equal to 10. That is what it means. All right. Now let's try to now if we draw a line over here, let's just put some dotted lines over here from here to join this part. Now you could see that from the center, this line actually divides AE into two. So it means that this side is what? Let's put here a letter. Say, let's put here M. And then let's put here N. Let's make it capital N. And then let's make this one capital M. All right. All right. Now, so we have ON and then we have OM over here. All right. Then let's do the same thing over here. Let's say that we have these dotted lines over here up to this point here. And then here, let's try to put a letter here. Let's say a letter, what letter should we use? Let's use the letter K. So let's say we put letter K over here. So let's write that 12 here. So let's put the letter K over here. So K over here. And then let's put the letter, let's say I over here. Because of space, let's put letter I over here. All right. So we put I over here. All right. Now what we're going to do is this. We need to find DC. If we're able to find DC and then CB, then we can find the area of we have dimensions of the rectangle to find the area of the rectangle. All right. So we shall say that area of shaded region. First, let's write. So area of shaded region is equal to area of rectangle minus area of triangle minus area of semicircle. Right, so that is it. If that is what we're saying, then let's make use of this space over here. What are we going to do? How are we going to find the dimensions of the rectangle? Now let's come here. We can see that from here, A to F is equal to 12. And then we see that when we extend this line from here, from O to M, all right, and then from O to N, we can see that from this point O to K divides AF into 2. So AK will give us 6, since AF is equal to 12. So AK will give us 6, and so KF is also 6. That is what it means. Then it means that if from O to N is the same as O to F, which is 10. So this is going to be ON, which is 10, 10 plus 6, that is AK plus ON will give us AD. You understand? So it means that from here to here is 6. 6 plus 10 is 16. And then AF is equal to 12. So if you subtract 12 from 16, what is left? It means DF is 4. So it means we have DF to be equal to 4. So let's put 4 over here. So DF is 4. Now let's come to this side. Now what are we going to do here? Here we can see that OI is also equal to OF, which is equal to 10. It's the same radius. That is, OE is the same as OI, which is also equal to 10. So if this is equal to 10, then AM is equal to what? 8. So that means 8 plus 10 will give us 18. But from A to E is 16. So that means EB is equal to 2. So EB is equal to 2. So we put 2 over here. So it means that we can now say that AB is equal to 18. So from the diagram, we can see that AD is equal to, so AD, let's put it at the top. So we say that AD is equal to 12 plus 4, that is equal to 16 centimeters is what we're having. Then we come to AB. So we come to AB. AB is equal to, that is 16 plus 2. So that is 16 plus 2, which is equal to 18 centimeters. So now it means that we have AB to be 18, and then we have AD to be 16. So it means we can find the area of the rectangle. All right. So let's continue. So area of rectangle is equal to length times breadth, which is equal to, what is the length? The length is the longest side now, which is 18, and then the length will be the shortest side, length times breadth. So the length is the longest side, which is 18, by the breadth is 16. So that will give us 16. And 18 by 16 will give us 288. So that is what it gives us. Let's find the area of triangle. So let's find area of triangle AEF. That is AEF is equal to half of the base times height. So half of the base. What is the base? The base is AE, which is 16. So half of the base. So half of the base, 16, times the height. The height is AF, which is equal to 12. And then half of 12 is, or half of 16 is 8. 8 times 12 will give us 96. So that will give us 96. That is the area of the triangle. Then let's find the area of the semicircle. So area of semicircle will be equal to, this is a semicircle, so it's going to be half pi r squared. And remember, in the question originally, we were given pi to be equal to 3.142. All right. So that is what we were given. So the area of this semicircle will be equal to half of pi, which is 3.142, by the radius is going to be 10 by 10. So that is going to be equal to pi, which is 3.142, multiplied by, this goes there, is 5, that is multiplied by 50. And so that will be equal to 3.142 by 50. What will that give us? Let's see. 3.142 multiplied by 50. and that gives us 157.1. So that will give us 157.1. That is what it gives us. So now, what are we going to do? We are going to find the difference between, we are going to find the sum of the area of the semicircle and then that of the triangle. Then we subtract it from that of the rectangle to find the area of the shaded region. All right. So now, what we're going to do is we can wipe this off so that we make use of that space up there. So here, let's rule a line here so that we make use of this space over here. So area of shaded region is equal to, that is the area of the rectangle, which is 288, minus, what is the sum of 157.1 plus 96. What will that give us? This plus 96 will then give us 253.1. So that will give us 288 minus 253.1, 253.1. And then what will that give us? That will give us 34.9. So that will be equal to 34.9. And 34.9 is approximately 35 squared centimeters. All right. So this is the answer to the area of the shaded region from this diagram. On that note, thank you very much for watching. Do subscribe to my channel so that you'll be notified anytime I post a new video. Thank you very much. Bye bye.